Hello there, I am Andrew Lewinberg,
My name is Nick Anderson.
and we are here to present our project for ECE 353. It is called Break the Bank 2.0.
Alright, so now we are going to actually start our game demonstration here. So on both boards we're going to hit reset, and we're going to show you the transmission portion first. It prints the title and requests that the lock code is entered. It describes the fact that you're supposed to set it with the joystick and then press the down button to submit it. So here, for example, I'm just going to push the joystick up and to the right for an example lock code, and then once I hit down, it's going to confirm that the lock code has been set. It's going to request that you set the difficulty with the push buttons. We have 4 push buttons and 4 corresponding difficulties: easy, normal, hard, and insane. So any one of these is fine. We're just going to do normal for now. And then the final part of the player 1 board transmission is just the up button press to transmit the lock code. And it confirms that it's been sent. And now it will shift control to player 2, who is going to try to break the lock.
Alright, so this is now the receive board, and during that entire process you just saw with the transmit board setting the code and setting the difficulty, mine has just been sitting and receiving data, basically waiting for him to set the lock. So it's been getting information, some handshakes, some data, and what I'm going to do is I'm going to go ahead and press the transmit button on the sender board, and you're going to see that my board recognizes that it is no longer a handshake, but it's valid game data. So just like that, it is now basically giving instructions on how to try and crack the code. So as you can see, the LED matrix right here has a single light on it, and as I move around with the joystick and I try and find where that value is, the lights begin to go up and up and up. And basically the way this is working is in the background there's an algorithm that is checking a difference between the value of the joystick I received from the other board and the current value of the joystick. And as I'm moving, it is going to go from 0 to 5 bars. So the game is actually kind of difficult. Give me a second here to try and actually solve it. There we go. So I've now found the correct value, as you can tell by looking at the LED matrix. It's fully illuminated. As I hit down here, it switches to a lock unlocked, or a safe cracked animation, and it gives you the message that you have cracked the safe. And then what you saw there for just a moment was actually us reading a data byte from the EEPROM. It is going to be a total number of safes cracked. I believe it said 10 if I saw it correctly. So basically what it does is it reads that data from the EEPROM and increments it, saying yes, you have now successfully locked another code. It displays it on the screen, and then it sets, or it saves the incremented value back into the EEPROM. Alright, we're going to go ahead and talk about the watchdog requirement of our project really quick. The way we've implemented this is one of the boards at any time is the generator of a handshake, and then the other board needs to notice that the data it is receiving right now is not actually game data, but it is a handshake, and then it needs to send a handshake right back. So at the first part of our program, the send board is going to be responsible for generating the handshakes, as you can see here on Putty. As we jump over here, we can see that the receive board is generating wireless packet statistics. It's looking for a flag byte, and it's noticing that the flag byte is showing that it is actually a handshake, not game data, and it's sending information right back over to our send board. A little bit later in the game, the roles reverse, but the practice is exactly the same. We're going to show you really quick that if you disconnect one of the boards, the other board is not going to be happy about it.